Hey, good morning. Today we're going to be working with more unit circle topics and as well as practicing our calculator for some of the more complicated functions or ideas around it. And uh, just doing some practice around finding trig functions of a little more complicated situations. If you have a purple, or if you printed out a purple sheet and you have been using it, add this in there. But today we're going to be focusing on two triangles. It looks like three, but really two triangles, 30, 60, 90 triangles, and then 45, 45, 90 triangles. On here it says use reflections to get to this point. I'm going to cut to the chase though. They're all here. Basically, we have a bunch of coordinates that are going to be used over and over. And they're all rooted from the two triangles that I said earlier. So on a 45, 45, 90 triangle, we have root 2 over 2 for x and y, and then we have some sort of form of that. So in the first quadrant, it's going to be both positive. In the second quadrant, it's negative root 2 over 2, comma, positive root 2 over 2. And then in the third, both are negative, and then in the fourth, the y value is negative, just like normal coordinates. But you're only using root 2 over 2 for both x and y here. Over here, we have a 30, 60, 90, the first version of it. These are forms of 30 degrees. So when 30 degrees is part of that angle in the center. And they're going to be some form of 30 degrees. So this is 30. This angle in here is 30. So using reflection, and then this angle right here is 30. That's not to say that all of these are 30 degrees. This is 30, this is 150, this is 210, and so on. So just using that idea coming from the starting point, getting to the terminal side, but the reference angle, or getting back to an axis, is going to be 30 degrees. With this case, the x value is going to be some form of root 3 over 2, either positive or negative, and then the y value is going to be 1/2 or negative 1/2, depending on where you're at. For the 60 degrees, same triangle, different, but a different angle that we're using from that triangle. The x and y values switch. So now x is going to be the 1/2 or negative 1/2, and then the y value is going to be root 3 over 2 or negative root 3 over 2. And again, the 60-degree angle is referring to the reference angle, which is just the smallest angle to get back to the x-axis. So this is 60, this is 60, this is 60, but coming from our starting position, it'll be either 60, 180 minus 60, 180 plus 60, or 360 minus 60. But just fitting this triangle in that location. So I think on the purple sheet this might be small, so if you are using that purple sheet, you might print out a different one, but just make sure that you have a unit circle. It'll be super helpful in any of our lessons to come. All right, finding the exact value of these, you're going to be using that idea along with quadrantal angles, but I like to draw pictures, and pictures are going to be super helpful throughout. So when in doubt, draw a picture. But that is pi, 2 pi, 3 pi. This coordinate on the unit circle would be negative 1, 0. The y value of that coordinate is 0. So sine of 3 pi is 0. Cosine of negative 270. We're going to move counterclockwise, so that's 180 degrees. Another 90 degrees would get you to 270. So negative 270 is located here. Same thing as 90 degrees, basically. This coordinate is 0, 1. The x coordinate of that is 0. Tan of negative pi over 2. Pi over 2 is 90 degrees. negative pi over 2 is negative 90 degrees, so it's going to wind up right here. And remember, tangent is basically the slope. So think about the slope of this line. The coordinate is 0, negative 1, and x is y over, or sorry, tangent is y over x, negative 1 over 0, which is undefined, but the slope is also undefined. So you can always revert back to what tangent is finding, and it's finding the slope. So tangent is undefined. Get rid of those. Three pi over 4. Anytime I see pi over 4 or some form of it, I know that this is going to be using a 45-degree angle. So keep that in mind. Basically, it's going to be root 2 over 2 or some form of it. Pi over 2 is 2 pi over 4. 3 pi over 4 is in this quadrant. So we're working with this angle. If it's on the unit circle, we're working with negative root 2 over 2, comma root 2 over 2. And then sine is going to be the y value. So root 2 over 2. 5 pi over 4, again pi over 4 is going to be some form of a 45-degree angle. Pi would be 4 pi over 4. So 5 pi over 4 is just one more. And same numbers, except the y value is going to be negative. And we're looking at cosine, that's our x value, so negative root 2 over 2. $315. If you do 360 minus 45, that's 315. So that's going to be a 45-degree angle, or a reference angle of 45 degrees. And it's going to be right here. If it's on the unit circle, we're working with root 2 over 2, negative root 2 over 2. Tangent, again, is the slope. So think about the slope of this line. Y over x would be negative root 2 over 2 divided by root 2 over 2. Giant 1, but now it's negative, so this is equal to negative 1. Okay. Next, we're going to be working with 30, 60, 90 triangles. So sine of negative 60, and because 30, 60, 90s, there's two scenarios, either you're working with 60 or you're working with 30. Root 3 over 2 and 1/2 often gets mixed up for me, so the way I try to remember it is that 60 is, if it's positive 60, is shooting up quickly. So that means that the height is going to be more than the base. So in this case, this would be the root 3 over 2, and this would be the 1/2. Whereas if it's 30 degrees, it's shooting out faster than it is shooting up. So this is going to be the shorter end of the two. So I know that's not a super crazy way of thinking about it, but that's just how I try to think about it. Is it shooting up or is it shooting out? And based off that, I'm gonna figure it out. So sine is the vertical portion. It's shooting down because 60 degrees is bigger than 30. So this portion is root 3 over 2. It's negative, and this is 1/2. So it would be 1/2 comma negative root 3 over 2. Sine is the y value, so negative root 3 over 2. 210 is 180 plus 30. So I'm always trying to figure out how many 180s can I take out, how many 360s, how many 90s, and I try to stick with 180 and 360s if I can, but just how close is it in relation to both of those numbers. That's always a thought in my head when I'm getting ones that are not acute. So this is 180 plus 30, so I'm working with a 30-degree angle. And 180 plus 30, I'm working with this triangle. And it's going to be a 30-degree reference angle, so it's shooting out. Negative root 3 over 2 is going to be my x value. My y value is negative 1/2, but that doesn't matter for cosine. Negative root 3 over 2. All right, 5 pi over 3. Just like with fourths, I know it's a 45-degree angle. With thirds, I know it's a 60-degree angle. Sixths is 30. So you won't really see an unreduced fraction. If it is reduced, then thirds is 60. Sixths is 30. So that's another tricky portion of it. But with thirds, it's a form of a 60-degree angle. 5 pi over 3, that's 1 set of pi over 3 short of 2 pi. So we're working with this angle, where this is 60 degrees, or pi over 3. 60 degrees is shooting down rather than out, so the x value is 1/2, the shorter one, and then the longer side is the height, negative root 3 over 2. Tangent's trying to find the slope, so we're going to divide negative root 3 over 2 divided by 1/2, y over x. The half portion cancels, so negative root 3 divided by 1 is just negative root 3. Okay. All right, if the angle's not one of these, we don't have a shortcut for it, unless it's quadrantal, but basically it's going to be one of those special triangles, or at least on the unit circle, it's going to be one of these special triangles, or it's quadrantal, or we have to approximate the value. There's no way around it, other than if we're not using right triangles, then we can go back to some Pythagorean triples, things like that. But that's the nice part with unit circles, is it's going to be an easy one, or it's going to be a calculator, which isn't too bad. So we're going to go to the calculator for this. And on the calculator, make sure you're in degree mode, but for 40, or at least for the first two. Cosine of 48 is good, quick and simple. Cosine 48, and round to the nearest hundredth, so 0.67 will be 0.67 is going to be our answer there. Cosecant of 21. There is no cosecant button, at least not on the home screen, and I don't feel like hunting for one. Yesterday we talked about how cosecant is the reciprocal of sine, so this is the same thing as 1 over sine of 21. Do not plug this into the inverse of sine. This is not the same thing as 1 over sine, even though that's how exponents rule, or how exponents work. This is not the same thing as 1 over sine, so just be clear about that. It would probably get grumpy with you if you tried to do that. Let's try it. I think sine of 21, it's an arrow domain, because this is a ratio between the hypotenuse and the height, which the hypotenuse has to be longer than the height. So plugging in 21 would say that the height is 21 times greater than the hypotenuse, which doesn't make sense within right triangles. So it just gets grumpy with you when you try to plug in numbers that are bigger than 1. We'll get it more into inverse trig, domain, things like that. But just know that cosecant is 1 divided by sine of 21. Which is about 2.79. Tangent of pi over 12, the trick here is you just have to switch between radians and degrees. So radian, tangent of pi divided by 12. I'm going to make sure. Yeah, okay. So it gives you the same thing, but 0.27 is the solution here. Just get comfortable with your calculator, switching between modes, making sure that you're finding the correct sine function or trig function, and nothing much else to it. Okay. Going to number 3. So what happens when we're not working with a unit circle? I always go back to a unit circle, or think about what type of what triangle I'm working with the unit circle. That way I don't have to have a hypotenuse of something other than 1. But you might be able to find little tricks to figure this out without converting it back to a triangle in the unit circle. But again, a picture will help you. So draw a picture when you're not sure. This picture is a graph. Oh no. -1 is right here. And think about the slope. Our slope here is going to be -1. Tangent of tan of 45-degree angles are 1 and -1. So we're working with a 45, 45, 90 triangle. Plain and simple. But if you didn't realize that, you can still draw a triangle and make sure you can get there with other means. So even though it's a triangle, we are going to put negatives in there just so we can keep cosine and sine the correct value. If you find the hypotenuse, it is -1 squared plus 1 squared, which is 2. That is c squared. So c is equal to square root of 2. If you were to find a similar triangle to it, remember similar just means the same angles, just different size and different sizes of sides. If you divide everything by √2, the hypotenuse is 1. So if you divide by the hypotenuse, you're going to get back to the unit circle triangle version. 1 over √2 is, if we rationalize this, is √2 over 2. And again, this is a 45-degree angle that we're working with, -45 degrees, or 360 minus 45 degrees, which is 315. Same reason, -1 is going to be -√2 over 2. Okay, so we're working with this scenario, still on that graph, and now it's on the unit circle. But now sine, cosine, tangent, all of these 6 are going to be back to the basic triangles that are basic functions that we've been using. Cotan theta. √2 over 2 for, -√2 over 2 for sine. Cosine is going to be +√2 over 2. Tangent is going to be the slope, which we said was already -1, or you can do sine divided by cosine, y over x. Flipping that fraction, I'm going to go back to the unsimplified, or the unrationalized denominator, because flipping this is a lot easier than flipping this. Flipping this would be √2 over 1, which is just √2, but that is secant, because cosecant is -√2. Cotangent is flipping -1, -1 over 1, 1 over -1. It's all the same. So go back to a unit circle if you're not given a unit circle, or you can work with the basics of SOHCAHTOA. Working on here, we have a little tricky situation. Cotangent is -2, so find cotangent of theta plus pi, so it's going to be in a different location. It feels like that's going to be impossible just because we don't know what theta is. You do not need to know theta to figure this answer. You need to know kind of where it is for your picture, but other than that, it's completely doable without knowing what theta is. So don't use inverse trig on this. Tan theta is -1/2. Our slope is -1/2. So let's go draw. All right, beautiful slope. So this angle is theta, or this angle is theta. It doesn't really matter, but the slope here is -1/2. There's another place where it's -1/2 over here. So the slope here is also -1/2. It's the same line, and lines have an angle of 180 degrees. Because this is 180, it's also pi. So if I add pi to this angle, I'm going to be over here. But tangent is -1/2 over here as well. So tan of theta plus pi is -1/2. So cotangent of theta plus pi is -2 still. So this is -2. Nothing changes when I add pi to cotangent. Cosine of theta is 2/3. So cosine of theta is adjacent over hypotenuse. Secant of theta, sorry, this is 2/3. So adjacent and hypotenuse. Adjacent's 2, hypotenuse is 3. If it's not on the unit circle, we can have a hypotenuse of something other than 1. It's a similar triangle, so we could just pretend that we weren't working with the unit circle at all, even if we were. The secant is the hypotenuse over adjacent. Well, the hypotenuse is still 3. The adjacent is still 2. So secant of theta is 3/2. So again, go back to unit circles if you can. Sometimes you can ignore the fact, so really flexible on what you can and can't do within trig, which is kind of cool. If a problem is too hard, you can always make it simpler using some other strategies, like going back to the unit circle or ignoring the unit circle. Lot of tricks, air quotes, tricks when you're doing this. But that's all I have for you today. Make sure you're using MyOpenMath 30 minutes a day if you're doing high school credit, this video included. Everybody else, make sure you're doing all of the MyOpenMath. That portion is going to the college grade. All right, till next time.